I welcome you to this session on geometry and mensuration. In this session, we will take a look at some basic properties of angle bisectors. For those of you who are aware of the properties and just want to have a quick recap, can take a look at the last 1 or 2 minutes of this video, and I have summarized all the properties there. Others can just go through this video completely at their own pace. First and foremost, what is an angle bisector? Angle bisector is a line that starts from any vertex of a triangle and bisects the vertex angle. For example, we have a triangle here and the three vertices are vertex A, vertex B and vertex C. And here we have a line drawn from A and we have a line drawn from A which cuts the line BC at point D, and this AD divides angle A into two equal parts as is indicated here. So this is also x degree and this is also x degree. So AD is our angle bisector. First and foremost, if you draw the three angle bisectors of a triangle, so we have the triangle ABC and angle bisector AD, angle bisector CE and angle bisector BF. These three angle bisectors meet at a point and I designate this point by I. I is known as the incenter of the triangle. So what is the incenter? Incenter is the point of intersection of the three angle bisectors of a triangle. And what is so special about this incenter? Incenter is the center of the incircle, and incircle is the largest circle that can be drawn inside a triangle, and with the circle touching each sides of the triangle. So here you can see the incircle of a triangle and the circle touches the triangle at points D, E and F. So we can also say that incenter is equidistant from the three sides, and this distance of the incenter from any of the sides is termed as small r, which is nothing but the in radius. Next we move on to what is an x-center. So if we have a triangle ABC and we extend any two sides, let's say in this case I have extended AC and AB, then we draw bisectors of one internal angle. In this case I have drawn a bisector to internal angle A and two exterior angle bisectors as I have shown here. So we can say that AX is the angle bisector of the internal angle A, CY is the bisector of this external angle C, and BZ is the bisector of the external angle B. So they all meet at one point. Let's call this point as E. This point E, which is the point of intersection of one internal angle bisector and two external angle bisectors, is known as the x-center. And this x-center has been denoted by the point E here. Now you can easily see that we can draw three x-centers, because with x-center as the center, we can draw a circle that is touching one side, one actual side of a triangle, in this case the side BC, and the side AC and AB produced. So as you can see here, this is an X circle with center E, which touches the two sides extended and one internal side of a triangle. And you can easily see that we can draw three X circles to a triangle, and therefore there will be three X centers in the triangle. So now let us look at some properties regarding angles formed at the X center and the incenter. So once again, let us say we have a triangle ABC and three angle bisectors AD, BE and CF, which meet at this point I. So what can we say about this angle BIC formed here? Angle BIC must be equal to 90 plus A by 2. Similarly, angle AIC is equal to 90 plus B by 2, and angle AIB is equal to 90 plus C by 2. So then let us turn our attention to angles formed at the X center. So let us draw one. We have triangle ABC and we have the three angle bisectors. AM is the internal angle bisector. CM and BM are the two external angle bisectors. They meet at M. So what can we say about angle CMB? Angle CMB is equal to 90 minus A by 2. And we can similarly write down the formulas for all the other three angles formed at the X centers. Now we take a look at one very important theorem, the angle bisector theorem. Once again we draw a triangle ABC and we have an angle bisector AB. The theorem states that an angle bisector divides the opposite sides in the ratio of sides containing the angle bisector. So in this case we will have AB upon AC is equal to BD upon DC. So AB and AC are the sides containing the angle bisector AD, and therefore the opposite side BC is divided in the ratio of AB upon AC. This is the very important angle bisector theorem. Now let us look at the external angle bisector theorem, which is in fact very similar to the internal angle bisector theorem. In this case, we have a triangle ABC. We have AD as the external angle bisector, so it is the bisector of external angle A, and AD meets the internal side BC produced at D. So the external angle bisector theorem says that AB upon AC is equal to BD upon DC. So you see that whether it is external or internal angle bisector, the formula almost remains the same. Just that in case of external angle bisector theorem, the side BC has been divided externally in the ratio of sides containing the angle bisector, that is AB and AC. So let us now quickly summarize the important properties of angle bisectors. First, point of intersection of angle bisector is known as the incentre. Next, the incentre is equidistant from all the three sides of a triangle. Next, if we can draw a triangle ABC once again and the angle bisectors AD, BE and CF, and if I is the point of intersection known as incentre, then angle BIC is equal to 90 plus A by 2. And similarly, if E were the X center, then angle BEC must be 90 minus A by 2, provided E is the X center of the triangle. Then we have the angle bisector theorem, which applies for any triangle ABC, which states that if AD is the angle bisector of angle A here, then AB upon AC must be equal to BD upon DC. Moreover, if AD dash is the external angle bisector of angle A, still we have AB upon AC must be equal to BD dash upon DC. So with this we come to an end of our session. In case you wish to watch more videos or wish to solve more questions, you can log on to our website www.pfindia.com. You can write your doubts to us at studentservices@pfindia.com if you have any. For those of you who are watching this on our website, you can use the Ask a Doubt feature to raise any queries or any doubts that you may have. Thank you very much.